about the fundamentals for a straight line in 2D plane, that is, the angle, the slope, and parallel and perpendicular lines. We're going to talk about more advanced topics later on. Now, for a straight line, it's important to know that there's concept of inclination angle depending on the orientation of straight line in a 2D plane. And usually, we limit the value of alpha, which is the inclination angle for straight line. And the special case where if it is parallel to the x, do you think this angle is 0 or pi? That is 0 degree or 180 degree? You can say both, but as a convention we say that's 0 degree. That is, the line is parallel to x-axis. Alright, so with that, we know that the range of the alpha could be from 0 degree to greater than 90 degrees here in this case, in this diagram. And when it goes to parallel, further, if you rotate that, that's become less than 90 degrees again. Alright, so you cannot go beyond 180 degrees. Okay, and this is a special case where if this is vertical, then we say this is 90 degrees or pi over 2 in radian, right? So this is some special cases for inclination angle. Now in general, we have angle, we limit to angle in this range, right? 0 to pi, yeah? Pi, or sometimes in degree would be 180 degree, yeah? Now the equation for a straight line is y equal mx plus c. This is one form of the line equation here. This m would representing what is called the slope. The slope measures how much you're going to change as you increase x by a unit. Now, when you increase by x by unit, the slope represents the amount of changes in y. Alright, so for example, if m equal 1, if you x increase by 1, y would increase by m, which is in this case is 1, right? So that's kind of the meaning of the slope. It's really important to understand that. And the slope could be negative. That is, when x getting bigger, y is getting smaller. You know, in the earlier diagram, when this alpha is greater than 90 degrees, that is indeed the slope could be a negative value. Okay, so here a line equation with this we call it is slope and intercept equation. Here the intercept represents the value when x equal to 0. So when x equal to 0, and then y will take the value of c. In this diagram, this point is going to be the y-intercept, right? Now there is also the concept of x-intercept, which is this point on the x-axis. This is where y equal to 0, so we can plug in y equal to 0 here, and then solve for x. That would be the x-intercept. Okay. Later on, we can learn an equation could be written in terms of intercept. If you know x and y intercept, you can have the line equation a different format. We're going to talk about that later. Not in this video, but in more advanced videos. Okay. So what is the range of the slope of m? Okay, earlier we said the alpha we limited in between 0 to 180 degree. Yeah, in the alpha, that's the range. How about the slope m? Now m here could be 0, in which case the line is going to be parallel to the flat horizontal line, right? Or could be positive in this diagram, and could be negative when the line the orientation go as x increases, y go downhill, right? So that's could be negative. And this is the case for m greater than 0. This is for the case when x is actually, the m is smaller than 0, the slope is negative, and it goes downhill when x getting bigger and bigger, you know, this straight line. Okay, that's important to know the meaning of the slope value, right? So a flat line, the horizontal line, alpha equal to 0, and m is also 0. Okay, and if the vertical line, however, alpha is 90 degrees, but m, the slope is undefined. Right, that's some special cases here. And what is the relation between the slope and the angle? Is actually, if you learn trigonometry, that is tangent of the angle here. Tangent alpha equal m. Okay, and if you know the tangent value is undefined when alpha equal 90 degrees. Tangent 90 degrees is undefined. Everything else is either positive or negative. Yeah. So let's take a look at this example here. We say that we have theta is a real number, and we have this equation here. Notice that we have a variable theta, which is a constant value, and xy. Yeah, this is a non-equation indeed. You know, what is the angle range, right? So inclination angle here, we need to find the slope, and then we know that tangent alpha equals the slope. So what is the slope here? Okay, so for the slope, we need to turn this equation into the standard y equal mx plus c form, right? Let's first do that. So let's turn that into standard slope and intercept form by dividing square root of 3 on both sides and move things around. We want to say y equal mx plus b. This m here is the value of the slope. Now, sin theta, however, is something that we don't know, but we know the range would be from -1 to 1, right? So because this is a sine, right? So you know the range of the slope, even though the slope is not, is a function of theta, right? From there, we want to get an idea about the range of angle. All right, let's do that. So since tangent alpha equals the slope here, and sin theta is between -1 to +1. All right, so tangent alpha would have this range. Okay, so we know that earlier we know that the angle is defined between 0 degree to 180 degrees. In this range, and tangent has to be smaller than the absolute value, has to be smaller than square root of 3. So in that case, alpha is going to be, between 0 to 30 degree. And notice that this is closed interval here, inclusive, and here is open interval here. That means when the flat line also satisfies this range, but we know that the angle is 0 degree, as we mentioned earlier. So this is an interesting problem. It's more advanced than the basic ones, right? But the concept is fundamental here. We know that the relation between the angle and the slope. Okay, let's move on. So this is another question saying that all straight lines that pass through this 2, 1 fixed point can be expressed in the form. This form is a variation of the standard y equal mx plus b because it goes through this line, so it uses this form here. But the concept here, this m is the intercept, right? Now, is this statement true or false? Okay, so the interpretation of this line is that m representing the slope. So in this case, the line has goes through 2, 1. So indeed, if you plug in x equal to 2 and y equal 1, all right. Indeed, so everything here, as m varies, is always passing through this fixed point, right? So when m is negative, it could go that way, yeah. So, but is this true or false? Now the answer is that it's actually false because it does not consider the special case of a vertical line also could go through, 2, 1 fixed point P here. So in that case, m is undefined. So you cannot write the equation for this straight line in this format. All right. So the right equation for the vertical line is x equal constant. That is, in this case, x equal 2. So the straight line is represented by the equation x equal 2. and the slope is undefined. So x equal 2 is the 9 equation. So that means the statement is false, right? Because it does not cover the special case of vertical line. All right, let's move on here. This is another problem from this high school math evaluation. Here is back in 1992. Here we say that m is positive and the points 9 on a line with slope m. We try to solve for m. Okay, it's very straightforward, and it actually requires another knowledge that when straight line goes through two fixed points, the slope is the difference of y over difference of x. Remember earlier we mentioned that slope represents the rate of change, of y with unit change of x. That is the ratio of delta y over delta x for 2 points on the straight line. Since we're given these 2 points here on the straight line, and by definition m equal the ratio of the change of y over change of x. Let's plug in the equation here. So m, this is representing change of y, 3 and m, right? The difference between 3 and m, and change of x from m to 1, right? So that's the definition of a slope. Now this, you can turn that into a quadratic equation here, yeah, and then this minus m would cancel, m squared equals 3, and we're given that m is greater than 0, so that's kind of easy now. This m would be square root of 3 because we're given m is positive. So it's quite easy, but you have to understand the meaning of slope. That is the delta y over delta x, right? So y1 minus y2 divided by x1 minus x2. So that's the important concept here for this problem. All right, let's move on. That's the answer. Okay, it's the C. Okay, so we talk about the concept of parallel line. So two straight lines are parallel, right? This kind of, you can have the horizontal translation here, right? Notice that here the angle will equal to each other. The inclination angle alpha, beta, they have to equal to each other. Now, of course, if alpha equals, the slope would also equal, because slope is tangent alpha and tangent beta, right? So both angles and slopes are equal if two straight lines are parallel. Okay, that's important to know. And the xy intercept, of course, they are different. In this case, x-intercept, this is negative, this is positive. Y-intercept for this straight line is here, but y-intercept for the other line is somewhere not drawn here in the diagram. It's going to be a negative value. All right, so that's important for the parallel line. The slope and angles are equal to each other. Okay, so this is another question here. We try to say a straight line is parallel to this straight line with this equation, and the new straight line passes through this 1, 4. We try to find the equation of the new straight line, right? The 9 equation for that. Now notice that the slope are equal to each other. So for this one, what is the slope? We're going to turn that into the standard y equal mx plus b form, right? So let's move the equation to this, which means m is -2, slope is -2, and the 9 is parallel, so which means the new straight line also have m equal -2. So the equation would be 2x plus b. How to find b? And we know that the 9 has to go through 1, 4. So 1, 4 is on the 9. Just plug in the value here. You get 4 equal -2 times 1 plus b. So b equals 6. That is, the equation is solved. Is -2x plus 6 would be the equation for that 9. All right, that's parallel line. Slope and angle equal to each other. Let's look at perpendicular lines. In the perpendicular line here, as we notice this diagram, this is 90 degree, so beta here is going to be 90 degree plus alpha, and then if you do that, and then you know the relation between tangent alpha and tangent beta, right? So let's say the slope, sometimes people use k, sometimes people use m, and this time, let's say the slope is k1 and k2, right, for two different lines, and then we have this from the trigonometry, we know the tangent beta and tangent alpha is going to be, because 90 degree, right? So the product of the two is -1. Okay, so that's what we learn from the trig, right? So the product of the slope is -1, and the inclination angle is going to be differed by 90 degrees. Okay, so that's for perpendicular lines. Let's look at an example here. We say that two straight lines with parameter A and C, B and C, are perpendicular to each other and they intersect, which means a common point, 1, -5, satisfy both lines, because this is an intersection point, right? So we try to find C. So we have unknown A, B, C. We don't care about A, B. We want to find C. So let's turn the given into a mathematical equation. Okay, this is always you want to do for a word problem. You want to turn that into a mathematical equations. Okay, let's do that. So the slope has to be, product of slope is -1. And what is the slope? The slope here is, if you move y to the right hand side and divide by 2, a over 2. Okay, in this case, if you move 2x to the other side, it becomes -2 over b. Okay, so, and this would cancel, so a over b equal 1, which means from here we know that a equal b. Okay, so once a equal b and also 1, -5 is an intersection point, you just plug in, right? So it's a plug in here, 1 and 5, -5, sorry, that will be +10. And then with this, you can solve the equation here, c equals 13. Okay, that's straightforward. Alright, so we have covered the basic of straight line, and later on we're going to cover a more advanced topic about, for example, point to line distance and some other things about, maybe 3 points on a line, what's the condition, for the 3 points, and also how about the straight line and the circle, tangent line, and things like that. And then please like, share, and subscribe to the channel.